Hey, good morning. Sorry, I've got a weird setup where I have to turn my head to look at the screen, but I met a friend through one of the Facebook groups, I think, that's within 2 hours of where I live that was looking for some assistance on buying and or setting up a new little hobby style CNC router. So he came over and I just showed him the ways I use the software and things like that a little bit. But what he did is he ordered a machine that I don't have, so I went and looked up some video, and I found a good video here of how to assemble this Two Trees TTC 6050 machine, and it's definitely a hobby style. The only thing I see that I don't think is very good about it is, or the main thing, the spindle that comes with it is only capable of 12,000 RPM. So on a small diameter tool like you might be using, you really need to be able to turn maybe 20,000 RPMs. But other than that, you can just slow your feed rates down and get by with that. Otherwise, it looks like a fairly rigid machine for a hobby style. So I got a little, Howard is the man's name that I met, and I'm not going to say his last name. I'm just making this for his benefit if he wants to see this, and I'll try to go quick. I've got 7 points in this video. I don't really want to get into running a job, but I want you to relax when you assemble this. Watch this man's video, and I've emailed him a link to this, but the name of the video is Beginner CNC Setup Two Trees TTC. Let me just look right quick at his name. It's called Casual DIY, and that's the link. That's the name of this video. But other than that, he goes through and shows all the pieces, shows how it goes together, and that's good. Now, the first step I want you to do when you assemble any machine. Now, I've got this little baby 3018 set up here that I've been tinkering with. I've had a long time. It's sitting on top of my alt mill, which is a very nice machine sold by CNC Labs. That is more of it's still a hobby kit style. It's a machine that you need to be ready to tinker around and be that guy that likes to tinker and figure things out a little bit, because these are not open the box and push a play button or something. So all of these hobby level machines take a little bit of reading instructions and understanding them and then doing it. So the first step, Howard, and anyone else that's assembling any new machine, assemble it according to the instructions. Think about how you're assembling. Keep everything as square. Measure things as you're doing it. Think about keeping it square and everything. So in this case, and I remember this has probably been 3 years ago that I put this little thing together. I bought this more or less as a joke, just to see what you could buy for $200 or less. I'm a CNC machinist in a aircraft manufacturing plant, so I'm very familiar with running CNC equipment. But when I assembled this, one thing I remember doing is these supports here that support that X gantry there. I remember taking a caliper, and because these, when they bolt together, can slide forward and backward, which gives you the adjustment you need to cover your workpiece. But what I remember doing is coming in here with calipers and measuring how far each piece was to the framework, so that I at least got it as close as possible. That's 2 inches that I measure from the back of this, and both sides are within about 5 to 6 thousandths of an inch of being square. About the best you could do with something like this. And all I'm saying here is, number one on my little outline is assemble it per instructions, square. Keep everything as straight and square, and think about what you're doing. Try to keep your wiring a little bit neat. And this little cheap machine didn't have a real good way to do any of that. Now, I'll go into some of the assembly real quick as I can, because I don't want to dwell on this and make it take too much time. But they come with these offline controllers, and so does the one that Howard has bought. And I'm not into using these little cheesy things, and I know his is better and it has more. I've never even plugged this in, but you can plug this in so you don't need a computer hooked up to it. You're just going to take your SD file off of your computer when you design it, and then this has the little adapter style that you can put an SD card in, and so does his, but it has a little bit better screen than this, but it just lets you run the file blindly instead of on the screen, which I'll get into a little further along in the video. I may make two-part video here, but right now we assembled it. Now all that's going to be hooking up to your control, and the style of control in his is, let me see if I can move along in this video. I want to show you the difference here. He goes step by step in here. In fact, go to the first of this video.
I'm going to show you a quick process of how to set it up so you can do your first engraving as well.
Right there. So you see that little control right there?
As well.
Whoa. Right here, that little box is the same thing as this box is here. It's just a place where all the wiring hooks up to the motors. You've got X, Y, and Z motors here. And then all that's left is you've got a power supply here that powers up just the way, same way his is. This is part of the assembly. Before I do that, I like to use the USB cable. Gives you the capability of running on a laptop or on a computer so you can see what you're doing much better than using any kind of little control screen. You can do it either way. I'm just saying it's more comfortable for me to see what I'm doing rather than just push a button and hope for the best. So other than that, you got a power cord going to just a power supply. Same way the alt mill. All this is the same way the alt mill hooks up, the same way. Any GRBL style control, little hobby machines, this is how they hook up. You got a USB cable, a power port, and you turn it on right there when you're ready to start doing some things. Okay, that covers assembly, right? Just assemble it the best you can. All your wiring is hooked up, your motors, your spindle, and that's really all. All right, so you understand the assembly is just make sure everything is done according to the instructions. Now we're ready to hook up the machine, in my opinion, not with this offline controller. You can do that if you want. To me, it's a little harder for you to understand trying to use and figure out the features of that. You can do that later, in my opinion. Let's go this route. So I've got a little microcomputer underneath this table, kind of out of the dust and cleaner. If you're using a laptop, okay, I'm not into that personally because it keeps you tethered to a machine, and in this case, I use a wireless keyboard and mouse that I can keep. Right under here is my keyboard, but it's completely wireless. And I can take this anywhere in the shop, get away from the dust. I've got a little slide under this table. I can keep both of these, but I like to keep the mouse where I can be operating and ready to push stop or anything. Always be ready when you first start a program, especially to be able to stop and just, oh wait a minute, I forgot to do something, or that's not held down very good. I don't like, whatever's going on. So, but the first step to hooking up this to your computer, and I know Howard has told me he's not real sure how, and he's probably figured this out alone by now. He's been studying this quite a bit, but how do you get the file that you design, which we haven't got into that part of this yet, how do you get that into the machine? Well, you're not really getting it into the machine unless you use this, and you have a little, and on his it's the same way. You have a spot to stick the SD card into that will be your G-code file that you create through VCarve Pro is the most common good software to use for that. Okay, I'm not going to get into any other softwares because this is what I do and this is what I believe in. So if you use Easel or something else, I'm not even going into that because that's just not, in my opinion, the way to go. So we're going to stick with the way I do it, and that's what Howard wanted me to show him, is how would I do it, and he's trying to learn the best methods here, and there's a whole lot of videos that'll lead you astray out there, so try to just keep that in mind. So, we're going to hook that to the computer, remember? So we have the power cord, okay? But in this case, the USB port is just going to my little computer over there. So whatever style of USB cable came with yours, or you can find one online, whatever. You hear the computer, it sees that I plugged in a USB, and here's the power. It powers everything from the power supply, and all of these machines are hooked up the same way. My alt mill, the long mill over there, all of these hook up the same way. Power it up, USB cable to your computer. Then you have a power switch, so we'll turn on the control. Okay, that's all. Now we're hooked to the computer. Now let's go over to the software. G-Sender can be found just like I showed how. Go on Google AI and just say, where can I download G-Sender software? And it's totally free. And it's a software built by CNC Labs, but it's a open source and it's free. And that's one of the better, easier to use softwares out there. So, and as you can see on this screen, it's really easy to, now look at the top. The next thing we need to make sure we're connected. It says connect to CNC. And we're going to make sure you select something that's GRBL or something that does not say GRBL how, because that's a more advanced that only the alt mill, as far as I know, uses. So go to where it says COM6 right there. Let's just click that one. And it's going to try to connect. It should turn green, and I could hear the motors kind of click once it connects. See, it turned green, and if you hover over it, it says disconnect, so it's connected, and if you click it again, it'll disconnect. And there's settings in here to make it automatically connect if you want. But now I don't want to go into all these settings right now, but I can tell you on the left tab where it says carve is where you run from. Stats will kind of show you things that you've done or something, and there's tools in here that you can get to where you can get used to using if you want to. Most people use this surfacing tool. I don't prefer that method personally, but it is there. Anyway, down here where it says config gets you into your firmware settings, and all of that is inside the box on your machine. I run this same software on the alt mill, but the settings in here are not the same as they are on there. That's all contained inside the box here. Anything it sees here is in there. It's looking at the firmware of the machine you're connected to. That's not in this software. That's in the machine, okay? Keep that in mind, and don't tinker with things you don't understand. There's plenty of information about all this stuff online, or you can ask me questions if you want, and I might can do that. But don't go in here and change anything if you don't know. I mean, I'm running inches, so you can see that this says inches. Anywhere in the U.S., most of us run in inches. Everywhere in the machine shop where I work, we run in inches. Just don't fall for, I need to be running in millimeters, because you don't need to unless that's how you do in your own country or in your own little thing. So I'm just showing you a few of these, but don't go in here and change this stuff unless I tell you something that might help you. But I don't like having soft limits on, and my soft limits are off. That means it ain't going to stop some distance away from your homing switches and stuff like that. And you can change how fast of the speeds it's going to run at. This one is set for a maximum of X. See, over here on the left, you can jump to different types of settings, or you can search for a certain, but we're in motors right now. I don't want to get into this too. I don't want to take too much time. I'm just saying a lot of people don't like how fast or slow it goes. These settings are in millimeters, so 3,000 millimeters per minute. You know, to do the math on that, I don't have a calculator in front of me. It'd be 3,000 divided by 25.4 is something like 150 inches per minute or something. But anyway, don't mess with these, especially these steps per millimeter is to calibrate the distances it's moved. It's calibrated with your lead screws, and your steps of micro stepping and your motors. I'm not trying to get deep into that. I'm just telling you all these settings are in here. You can come in here and set them and then apply settings down here. So don't be messing with that unless you know what you're doing, but you do need to get in there and look through them. And like soft limits enable, like I was talking about, you can enable that. And yours is probably already enabled, Howard, and I personally would disable that soft limits and hard limits, because that's just you might be in a job running and it gets close to the edge, and you should have already calculated and moved and found all your limits, and you should know you're not going to hit that. If you don't, you shouldn't be running, period. So I disable any limits, because that's going to stop and it ain't going to move to that position. And you may be in a job and you might have another 1/4 of an inch you could have moved, but because that's enabled, it's not going to allow that. So that's why I disable that, and all that stuff. So let's not get into that right now. Let's go back to carve. Now, since we're connected now, here's the thing we need to do. And I don't want to dwell on this too much, but what I want to do, we want to check all of the movements and make sure they're right. So we all know from going to kindergarten or whenever they taught us this, X is this direction, X minus is to the left, X positive is to the right, Y positive is away from you, Y negative is to you, and Z plus is up and Z minus is down. That's just all the movements there is. So let's check, and we can set these jog limits here. See, here is where you can jog your machine in increments. That's being, just click the mouse one time on one of these and you get 30 thousandths of an inch of movement. You can go up and down with this and get more or less movement. You can hold it and see I'm going Y negative, Y positive by holding it. If you go to these rapid, you can go into this software and change these numbers. But I've got this going at 150 inches per minute. That's what this AT is down here is, can't think of what that stands for right now. But anyway, that's your feed rate. And this is your XY moves, is going to move an inch at a time. So if I click that once, it's move 1 inch. Same way with my X, 1 inch. That machine kind of sounds crappy, and it is crappy. Z is going to move 0.5, which is a 1/2 inch. Make sure you have enough movement in here to do all this, especially when you're setting a job up. Find your limits on everything. So let's go Z plus, and it moved up a 1/2 inch. You're gonna move it down a 1/2 inch. All that kind of stuff. Now, when you home your machine, it's going to set these gray numbers over here. So since this don't have any homing switches, you can go to find where you want your home to be. And homing is not super important. I wouldn't concern myself too much unless these numbers kind of help you as you're setting the job up to know, okay, here's my limits I have, like my Z. If I wanted to do that, then just put it there, power down your controller, disconnect from it, wait a minute or so, power back your controller, turn this on, connect back to it, and then wherever it powers up is going to be your home. That will zero these numbers out. Sometimes it might move these that you may have had set before a little bit. And to zero your G54 offset workspace, you'll find out when you design, you're going to tell it if you want your zero to be in the lower left corner, in the center, or on wherever you want your zero position to be. When you get to that position, just push X0, see that turns to 0, Y0, and then you're going to set your tool down on the surface. If that's the way that's the most common way. Set your surface. If you don't have a tool setter, which that machine does, that he has, I would still verify that. Bring your tool down, to and make sure see, I'm at the limit there, so that won't touch without a tool in there. Take a piece of paper and just turn these down, like on precise, I've got this to 5,000 increments. And so I would just find that where you could just feel some drag or maybe even get tight on your piece of paper, and then put Z0. Now that's where your job is zeroed. And so we've almost done that. I don't have a tool in here. I should have put one in here so I could show you something, but what I want to do next is find out if I go in here and let's say that's set to, let's set that for 2 or 3 inches, whatever. And let's go ahead and put a pencil mark on here or something. And then let's go move 3 inches. Now, take you a little bit and find a really, you can buy these steel rules, but get a really accurate deal or use calipers. You really need some calipers for doing this kind of work. And measure that move and go, okay, I said 3 inches and I got really close. Maybe it's 3.012 or some number close. If you're seeing with your eye that it's really close to what you just moved, then it's probably accurate. Okay, that's important. Do all of your moves. Now find out, like I said, find all of your limits. And I don't want to really go too long. I want you to understand that is go to look for your stops or wherever your home, that's really close to that edge. And then I want to come really close to this edge. Okay. And whenever you find that really close, now his has these little knobs, and if you move those, I think you have to have your motors probably not engaged. A lot of times you'll have to, but find your limits, and then when you do power it up or whatever, find out, you can say zero your X and your Y right there. That's, say that's the very extreme right there. So then when you move all the way to your other extreme, find out where that is as well. And we're using this like a measuring tape here, see? So what we're going to do is move until I can see I'm at my stop. In this case, because I don't have homing switches here, that I'm going to be moving, and it hit, so I know that's it. Now I don't want to be against my stop. I want to leave a little bit of room. So let's leave, you know, a 1/16 of an inch, 30 thousandths, something. So let's change this number right here. Like I told you, you can change these. So let's go down to 50 thousandths and let's move that. So I know I'm not against that stop. And see, I have 11.8 inches of travel. And so I would write that down on the machine or somewhere where you can always know I have 11.8 inches of travel available in my X, or whatever your number is. Find those extremes. Same way in the Y, same way I can go up with a certain tool before you start a job, because tools are different lengths that you're going to be using. Find out how far can I go up, and make sure I can go down to the depth that I'm going to be cutting before I ever start a job. Because if I hit the stop or hit a home position, a limit switch during a job, you just possibly scrapped your whole job, and you don't want that. So before you run a job, make sure you have all the moves that you need and that you're not going to be hitting a limit or anything. And if your machine's big enough like this one, or you know, and your workpiece is, make sure it's smaller than what you really can move, and know that your limit in your Z is not going to, you know, hit its limit. And you can move your spindle, loosen it and move it up or down if you have to make sure you have those moves that you need. All right, and to load a file, I'm not going to get into running one right now, Howard, but like I've told you before, when you save your file, whether it's on a USB drive or however, personally, I save them in the computer or in OneDrive. But if I want to load one, just go right here where it says load file. And see, I have them in folders, but it's the same thing if you had a USB drive or any other way, SD card, anything you want to save it onto, then you're going to be saving that as a G code file. It's .g code or .nc. .nc is one that they recommend. Either one will work with this or that, but .nc is probably what your post-processor, or sometimes .tap. But that's say, so here's some that I saved from the other day. So let's just, for instance, go pull one up that I did on this machine the other day. And so, and you can change how it looks by doing like that, so you can see. And see, here's where it was zeroed right here. I had it zeroed in the corner. And so you can see exactly where everything is located in your, where you zeroed everything. And down here, it will show you the extreme moves. So see on size, you can toggle this between info and size. So it's showing that it's going to go a minimum of 0 on the X, which is where it's going to start the job, is down here. It's going to do a maximum move in the X of 10.98 inches, which is right over here. And so on. It's telling you all of your moves. Now, without reading your G code, people are scared to understand what the G code means. This is a way around that. And then same way on the Z, showing you it's going to go. Now I've zeroed off the bottom on mine, so it's showing it's going to go down to a 0 minimum and a maximum of 0.75. And these are the numbers I'm telling you to look for, the max movement, and see if you can literally move it that far and not hit any stops in any direction here. Make sure, especially on your first job running, make sure all of your movements can go wherever this says it's going to end up going, and you can read that when you zero. The same way here, you can go back to your zero just by pushing this go, say XY, it'll move right back to where we had set a zero if we want to. And see, I went a little beyond that, so I need to bump that off of there and re-zero my X right there. So that's where it is. And that's, everything here is related to how many inches in your X, Y, or Z from where you set the 0 points right here. Be sure you're setting those and know and understand that. And make sure when you push start, okay, it's going to run. Now I'll go ahead and push start just to show you how this is going to move, but that's it. And you're ready to run, but let's get into a little bit of the design and stuff in the next solver. But when I push start, it's going to turn the spindle on and it's going to do all that. So just push stop right there. Now, when I do that, I like to, you know, get everything back to where it was, and then if anytime you need to stop, maybe a piece of something got stuck in it, you can lose your zeros that way. So always go back, verify where your zeros were. Make sure you didn't move anything. If it's still, always have your zeros set to where a place you can find. In the case that something moved or you lost something, make sure you can come back and find those, and then you can hold your right button to move this around. You can, you know, your center button will zoom in. You can zoom in with your scroll wheel. The left button gives you a little bit of a, depending on where you're doing this, you can tilt things around. You can also push these buttons over here and do some of that like that, and move things around. I'm just showing you this. It's really a simple software to use. I like to be able to see where I'm at right there and already know. You know, if you wanted to look at the front of this, you can go, okay, this is where my 0 point was. And, you know, you can make sure that, now I've already told you to 0 on the top, but I've done it on the bottom because I'm a little more of an advanced user and I understand some of this. I don't recommend you do that right off the bat, but anyway, that gives you a lot of control. And if you push info right here, you can see what your feed rates and speeds and things were set to be. I was set at 15,000 RPMs and stuff like that. So that's just kind of how that works. So anyway, I hope this is good enough to get Howard, especially Howard, to get you set up, get you comfortable about how to move your files in and out. And let's do another video here in a minute on running your first job and how to be sure that you're going to be safe to do that. And I ain't talking about safe, for personally safe, but you're not going to do something you don't expect, maybe tear up your machine, break an end mill, a tool, or whatever you're using, and just be comfortable with it. And you don't never lose that edge. I've been running CNC stuff for nearly 10 years, I guess, and I'm never not a little bit nervous, but know when you first started, it kind of shows you the moves it's going to make. And if you want to look down here, I didn't go into this, but you know, that's the probe moves that you can set tools and things, and you'll get used to how to, Howard, before you use that, you might have to be sure you understand how to set your probe up, and you can set that up in here, again, into your tools, config, and somewhere in here will be, right there it says probe, and this is set up for the alt mill or the long mill, and their probe is called, and you can buy one of these and use on your machine just as well, but it really fits the controller on this machine, and the one you have will work, but you have to go in there and do some settings in here. I can help you with that. I don't know how to do it out of my head right now, but I think you're just setting this thickness on here to tell it how thick your tool setter is and all that, and we can work through that. That's not a big deal, and make that work, but that stuff is in there. So let's not dwell on all this. Hopefully this makes you a little more comfortable, Howard, when you load your file. Like you had told me the other day, you're not real sure how you load the file in. That's how you load it in. Just be sure you understand how to set your 0 points, and once you run it on here, also an important step is make sure your feed rates and your speeds are going to be right, because that can make a big difference. And I can tell you some numbers that'll work for you, and just because it says a certain number in any tool stuff that you have, you know, that comes with the tool or whatever, I don't always agree with those numbers. I can give you a good number that'll work for you just from experience of doing it, more than anything. So all right, let's get out of here and let's go on to the next deal. I hope that wasn't too long and boring for you, but I wanted to be sure anyone doing this for their first time can just see kind of an overview of what you're going to do. And I firmly believe in using this software to make it the easiest for you. And anyway, hope it's been helpful. See you soon, hopefully on the next video.